This is Anita Michelle Strain. This is this is Module 2, Assignment 1. And we're looking at some SPSS statistics today on school-wide data through district-wide data. And we're looking at the difference between enrollment between Regions 1 and Regions 5. So the first thing that we want to do is we want to do a pre-test checklist. So we're going to look at quota, how many samples are there in the sample size. We're going to look at normality, if it's a normal distribution. And then we're going to look at the homogeneity of variance. So first, let's go up to look at the N value and the test of normality. So we're going to go up to Analyze. We're going to go to Descriptive Statistics. Then we're going to go to Explore. And when we are there, we're going to look at our dependent list, which we've already preset as enroll, and our factor list as region. Next, we're going to click on plots. We're going to make sure the histogram button is checked and not stem and leaf. We want to make sure the normality plots with tests is checked. And then we're going to continue and click OK. So what we're looking at right now is our sample size first, our N value. So Region 1's sample size is 72. Regions 5 is only 23, so it doesn't meet that barrier of 30 that we're looking for. But we are going to proceed in this test as if it does go ahead and meet those qualifications. So now what we're going to do is I'm going to look at the test of normality. We're looking at the significance of our regions right over here. And if the significance is, the variable is greater than 0.05, then it is significant. And so we're going to assume normality at that point. So we do have the significance here of 0.001, which in this case, it would be less than 0.05. So we're looking at probably not on Region 1. And Region 2 is greater than, or Region 5 is greater than 0.05, so it is. So let's look at our histograms to make sure we're right. So histogram for Region 1 is not a bell curve. And so we can see here that it is not normal. It does not fit into normality. And then we're going to look at histogram for Region 5. And while it's not a perfect bell curve, there is a general bell curve with the outlier of this over here on the left. So we're going to say that in general, we don't really have normality with Region 1, but we do with Region 5. So now we're going to take a look at the homogeneity of variances. And we're going to look over here. If we go back to our original data, which let me get to it, I'll show you how we do it. You're going to go to Analyze. You're going to go to Compare Means. Then instead of Independent Samples t-test, you're actually going to go to One-Way ANOVA. You're going to click this. In our dependent list, we've already moved over Enroll. And in our factor list, we've already put Region over here. And so what we're going to do next is we're going to look at the Options button. We're going to make sure the homogeneity of variance test is clicked. And then we're going to continue and click OK. So we're going to look over here at this data, and what we're looking at is if the value is greater than 0.05, then we can assume the homogeneity of variances. And we're going to look at the results. So we're looking to see if there is a significant difference. And so we're looking right here at the based on mean. and the between groups. And they're the same, essentially. They're less than 0.001. So that number, 0.001, is less than 0.05, which means there is a significant difference and we do have homogeneity of variance. Okay, so let's run that independent t-test. We're going to go back over to our data set, and we're going to go up to Analyze. Then we are going to go to Compare Means. And then from there, we're going to go to Independent Sample T-Test. Click on that. We are going to go over here to Enroll as our test variables. And we're looking at our groups as region, and we're looking at regions 1 and 5. So from there, we're going to, and to show you how to do that, you're going to define groups, and went ahead and entered 1 and 5 as my variables. So we're going to click OK, and it's going to run our independent sample t-test. So I will say mine is a little bit different than the one that was showed in the videos, because I am not seeing our F or our significance over here, but I did find it in our one-way ANOVA, our one-way ANOVA test. So so let's take a look at this information really quickly. We're going to look at group statistics right up here. And we're going to look at the sample size, which is 72 for region 1 and 23 for region 5. And even though we know we have a smaller size than we need for region 5, we're going to go ahead and move forward with that today for this assignment. We're looking at the mean now. So the mean is quite large for both groups, but even larger for region 1 at 2,353.75 for region 1 and 987.83 for region 5. Next, we're going to look at the standard deviation at 4,005.163 for region 1, and for region 5, we have 490.229. And we're also going to look at the standard error of means at 472.013 and 102.220. And that is some of our group statistics that we discovered with this independent t-test. So we're going to take a look next at the decision between equal variance assumed or equal variance is not assumed. And for this assignment, you've asked us to do equal variances assumed. So we're going to do that. I have actually found the F and the significance over here in my ANOVA score. So the significance of this test is less than 0.001. So we know if the value is greater than 0.05, which it is not, then we are going to make the decision that we are going to reject the null hypothesis since it's less than, and there is a difference that is worth looking into for this. Okay, now let's take a look at Cohen's d, or the effect size, which allows us to measure the magnitude of the mean differences. And it is now calculated after rejecting the null hypothesis, which we are doing in this case. So we're going to use the t-test info to calculate the different sizes. So what we're going to do is go back to our data set, and we're going to go up to Analyze. This is the trick that they showed us. So we're going to go up to Analyze. And then we're going to go to Descriptive Statistics. And then we're going to go to Descriptives and click on that. And what we're going to do is our variables is Enroll. And we're going to make sure to click on Save the Standardized Values as Variables button. And we're going to look for the Z variable. So if we go back to our data set now, and if we try again, we're going to run the t-test again. We go back up to analyze. This time we go to compare means and we go to independent sample t-test. Then we're going to look at the bottom and see Z score and roll, and we're going to click on that and move it over and move this back over. We're going to click OK. And now we've put in the Z variables. And now we're going to look at the mean difference. The mean difference is right here, 1,365.924. And when we look at the mean, the standard deviation, and all of that, we can see that. So our mean difference for both of these is 0.453. So the mean difference has a small effect. No, I'm sorry. It has a large effect since it's above 0.08. So it has quite a large effect here in this example. Starting with the assumptions, looking at the histogram, if it's bell-shaped, I'm not seeing an extreme violation of normality in region 5. But next, we're going to look at Levene's test for equality of variances. And since it is less than 0.05, then homogeneity is met. So that is good news. There is a significant difference in the district enrollment between Region 1 and Region 5. And in AP style, I can report this as T parentheses DF parentheses equals T value, P value, and D value. Because of our p-value is less than 0.05, we reject the null hypothesis. The Cohen's d of our d value indicates a large effect, meaning this is a difference, is practically important.